So these are typical this problem is a typical problem in standard position. We're given the position, -4, +9, maybe somewhere around there. So the -4, +9 position. And I'm being asked to find all the trig ratios. Okay, so I'm going to find my sine ratio, sine of whatever that angle is, cosine of whatever that angle is, and tangent of whatever that angle is. Now it's very important that if we're given two sides of the right triangle, we need to use exact values. Okay, we don't want to start using decimal values in a problem like this. So we're going to do 81 plus 16 is 97. So that's going to be square root 97 as our radius. So now we can use our definition of sine is y. Remember that connect the sine with the vertical. In fact, I'm maybe going to color code this. My sine theta is going to be 9 over root 97. Okay, it's important to connect the y value with sine, and we're going to connect the cosine value with x. So cosine theta is going to be negative, remember the positioning is important, root 97. So it's going to be -4, so this length here, we're going to connect cosine with the x coordinates. And then the slope is going to be a negative slope, so it's going to be -9 over 4 since it's sloping down in this direction. We are asked to find this angle in standard position. Now, it's always standard position now, so anytime you're solving for angles, we're always going to assume it's standard position. So I'm going to use the arctan. So I'm going to use the arctan. So my input is my ratio. My output is my angle theta. Okay, so I have -9 over 4. Okay, and I'm going to arctan this. So inverse tan. And I end up with -66.04 degrees. Okay, and that's my theta1. That's what comes from my calculator. Now, I know that theta1 is in the wrong position. And we always have to remember that because of the symmetry of the circle, we have to remember that there's always going to be two possibilities. So -66.04 degrees is measured down here. That's not the angle we want. The angle we're looking for is this angle here. Okay. That angle there is going to be my theta2. Now my theta2 does not come from my calculator. It comes from using symmetry. So I need to, the symmetry I'm using in this case is the opposite side of the circle. So adding 180 degrees. And I end up with 113.96 degrees. Okay, so that's my standard position angle that locates that angle. Now that happens to be theta2, sometimes it's theta1, but that dot there is located with 113.96 degrees. 66.04 does not do it, or -66, because it's in the wrong spot. Okay, so again, the position is important.